Hi everyone, does the mic work? Yeah. Okay. I'm really excited and honored to be here. So far, I think the festival has been great and I'm looking forward to what's coming next. But before going to the Wandering Albatross and how its mating strategy is putting it into troubled waters, I would like to introduce myself a little bit better. So, I was born and raised in a really small village in Quebec, Canada. So I'm a French Canadian. You might notice the accent. And as for C, I never thought about being a scientist when I was young. I actually wanted to be a hairdresser when I was a teenager. But I also happened to love math. And that's how it got me into natural sciences. And that's also where I fell in love with biology. I fell in love with biology because I thought that mating and reproduction was fascinating. And that's how I ended up studying reproduction and mating now still. So I did my bachelor degree and my master degree at l'Université Laval in Quebec, Canada. And that's where I started. I started by studying the harbor seal. I was studying the interaction between mothers and pups in the St. Lawrence estuary. After that, I took a little break to work and to apply my knowledge at the Department of Fisheries and Oceans in Canada, where I continued my work on the harbor seal, but I also worked on gray seals and all of the different cetacean species that live in the St. Lawrence estuary. I was mainly conducting aerial surveys and boat surveys of all of those marine species. But it wasn't enough for me. I wanted to continue to learn and continue to discover interesting things about reproduction. So that's how I ended up doing a PhD. My PhD was in collaboration with a research project in Scandinavia and in Université de Sherbrooke in Quebec. I studied relationships between mother and offspring, actually between a female and their cubs in brown bears. And I was interested in the cost of reproduction because we understood from Chrissy's talk that reproduction is really costly. It's what drives reproduction, the cost of it. And I guess that this was all very, very well in theory, but I really got to understand what it meant when I got a baby myself in 2018. It became really clear that reproduction is costly. I feel like I've lost a couple of years of my life in doing so. But it's a good experience. And now I'm a postdoc at Woods Hole Oceanographic Institution. I still study reproduction and mating strategies, but this time in seabirds. So it's a quite diverse range of animals I've been studying and all about reproduction. So enough of me, let's talk about the wandering albatross. In 1859, Charles Baudelaire, a French poet, published his poem, The Albatross. This poem is about bored fishermen who decided to capture an albatross for fun. The albatross is king in the sky, but on land, it's really ill-equipped to walk. So the albatross was walking clumsily on the boat's deck with its long wings flapping on the ground. So for sure, the fishermen had a good laugh. For Baudelaire, this poem is a reflection of how he felt as a poet in society, misunderstood and out of place. But when he chose his metaphor, he used the wandering albatross as this model species. And the reason why is because the wandering albatross is one of those species that thrive in its natural environment, but can very much struggle in an environment dominated by men. So the reason why I chose this poem to start my introduction is because I think it conveys the message I want to send you today, that the wandering albatross is magnificent. It has a really interesting reproductive strategy, but all of this magnificence, it's also what makes it really vulnerable, especially to human threats. So the wandering albatross now, it is a really, really big bird species. Here on the right, you have a human of a normal height, so not me. And beside it, there's a wandering albatross. So you can see it's an enormous bird. It has the widest wingspan of all birds alive. It spans 11 feet wide. Can you imagine carrying on your back 11 feet wide wings, how heavy that must be? It's super heavy, but it's also quite convenient because it allows the wandering albatross to be a really efficient flyer. It allows them to glide and soar following the wind currents. It's also how it got its name because of all of these, because of those really long wings, it allows them to wander across the oceans. The wandering albatross eats fish and mostly squid, and we find it all over the southern hemisphere. So we don't have them here, but we find them all over on the southern hemisphere. Another thing that is really interesting about the wandering albatross is its mating system. We say that wandering albatross are strictly monogamous, which means that once they find a partner, they will mate with that partner for life. Another thing that is interesting is that for them, breeding is so not a walk in the park. It's really complicated. Once they fledge, once they become independent from their parents, the chicks will leave the colony for several years. During that time, they will mature, but they will also build up the body reserves that they need to start reproducing, because reproducing is really costly. And that can take several years, between 6 to 12 years, and sometimes even 15 years before they start coming back to the colony they were born in and initiate reproduction. But once they come back to reproduce, it's not a done deal. They have to find a partner, and this relies on very, very complex courtship behaviors that can take months and even years to establish. So when they court, they do what we call the dance of the wandering albatross. So it's a series of behaviors that they do, either simultaneously or one at a time. And some of those behaviors are the same. They repeat the same behaviors over and over, but some others can be displayed or not, depending on, I guess, their feeling. Those behaviors range from stretching the neck, bending down, touching the other's beak, can be the emission of rattling sounds, or various variations around that theme. But the most impressive one is what we call sky calls, and I'm going to show you what it's like. A very interesting sound that should attract the ladies, right? So what they do is that they will spread their wings at its maximum, stretch the neck up, and emit a rattling sound like that. The reason why they do that is actually to show off. They want to show the other partner how strong and pretty they are. Both males and females can do it, but it's basically just putting on a show. And while they do it, potential partners will come around and have a look. They may push the sky collar back just to see if they can maintain that position. But another thing that they will do is that they will come forward and they will assess plumage quality. They want to see whether the feathers are pretty. Are they damaged? Are they pretty white or not? And it's quite clever, the reason they do that. They actually want to know if that individual is of high quality. Because in the wild, it's difficult. Life is hard in the wild. You have to find your food, you have to grow, but you also have to fight competitors and fight diseases. So if you're able to do all of that, and on top of it, be able to produce pretty feathers, then it means overall you're of good quality. So that's the reason why they look at plumage quality. So they managed to come back to the colony to breed. They found a fit partner. And another thing that I wanted to say here is that it's okay for them to be picky at that stage, because as I mentioned, they will mate for life. So if they don't choose wisely, they may end up having a failed reproduction that year and also for the rest of their life. So it's okay for them to be a little picky. But if they manage to find a partner that looks fit for them, then they will breed. But they will produce only one egg. And they will take care of that chick for about a year. That's really long. While we would think that both partners will take care of the chick, then it's not what happens in real life. In real life, since they have to stay for 12 months with the chicks, they cannot do it without eating, without going outside, out at sea to feed. So they have to alternate foraging trips. One partner will remain at the nest fasting, while the other partner will be out at sea feeding and acquiring resources. So because it takes a really long time, they cannot do it alone. And because the individual that stays at the nest fasts during that period of time, it's really important that the partner out there foraging comes back in time or returns, because if it doesn't return or come back in time, the partner at the nest will abandon its chicks because it cannot do it alone. In that species, it really takes two to tango. And once they manage to successfully raise a chick, then most of them decide to go on sabbatical. That was too much, let's take a break. So 80% of them will skip reproduction the next year. So they start reproducing late. It takes a long time to establish partnership. They only produce one egg every 2 years. So for the wandering albatross, it seems like reproduction is their Achilles heel. It's their weakest point. So now I want to bring you more, I want to talk to you a little bit more about the things that we do in our research lab and where we study the wandering albatross. So here you can see the tip of South Africa, and we're going to zoom in to the Crozet Island archipelago in the Indian Ocean. And here is Possession Island. It's pretty desolated. It doesn't have any trees. It seems, I wouldn't live there. But for the albatrosses, it's fantastic. And here is just a map showing you where exactly it is located. And here it's a research camp, well, the research base, where researchers are going to spend a couple of months there to study the wandering albatross. I've never been there yet, but it's in the plans for me to go maybe next year. And it's funny because when I told that to my mother-in-law, she was like, oh, that's fantastic. Just send me the address and I'll come visit. And I was like, that's not necessarily how it works. It takes about 2 weeks of boat trip to get there. And once you're there, there are no hotels or whatever, so too bad. My in-laws will not be able to visit me. The main objective of the study that we do there is to track every single individual. So each of them receive a ring there on their leg, which has a unique number that allows us to track each of those individuals. The monitoring program has started in 1966 there, so it's been a while. I wasn't born, so. And what those rings allow us, what it gives us as information, it's plenty. With only those ring numbers, we can know how long it takes for the juveniles to come back to the colony. We can know if they return or not. We can know if they survive to the next breeding season. We can know if they breed, but we can know also with whom they mate. So we can study pair bond dynamics. Oof. Okay. So remember I told you that the wandering albatross is strictly monogamous, but in nature it's never as black and white. And we know now with those studies that about 20% of them are unfaithful. So some of them will seek reproduction outside of their current couple. And on top of that, we also noticed episodes of divorce. Divorce happens when one individual reproduce with another partner while its current partner is still alive. And not only that, we also observed that it seems that some individuals divorce more than others. It's a repeated pattern. And it's funny because we know that's the case in humans. We know that in humans, there are some individuals that are more likely to divorce compared to others. Sometimes they're bolder or a little bit more aggressive. So that's the pattern, the typical personality type that divorce a little bit more in humans compared to shyer individuals that divorce a little bit less. We know that in humans we have different personalities. We all know that. But in wild animal populations, it's only very recently that we started to acknowledge that they also do have different personalities. So there are individuals that are a little bit shyer and others are a bit bolder. So we wanted to test whether it's the same in the wandering albatross as it is in humans. And to assess this, we needed to assess the personality of the birds in the wild. And typically how it's done is that we present an individual with a novel object, something that they have never seen before. And we measure how they react to that novel object. But I've shown you the image of the possession island. There's a lot of things that are novel in that environment. It's pretty bare. But we chose Betsy the cow as our novel object. The way it works is that we put Betsy the cow on a stick and we approach the stick to the bird that is on the nest and we measure how it reacts. We have a scale of reactions from 0 to 4, and on the 0 are birds that show no response towards Betsy the cow, and we associate that behavior with a shy personality type. And then there are more extreme reactions, such as a bird vocalizes or a bird stands up. And these would be associated with more bolder personalities. So here's a bold animal.
To my left, and then control the two.
Okay.
Betsy the cow is the novel object that is often used in other studies on other bird species. So that's why we use it. But we realized soon enough that the wandering albatross is much more aggressive than the other species because it didn't take long for Betsy the cow to be totally destroyed. So we had to be creative here. And now it's us, the novel object. We measured the reaction of the bird towards us approaching on foot. A little bit scary, but it works the same. So with that information, we found that there's actually a relationship between personality and divorce probability in the wandering albatross. So here on the x-axis is a continuum ranging from shy on your left to bold on your right. And on the x-axis, it's divorce probability. And this is the result we observe for males. And we can see that shyer males, so more on your left, have higher divorce probabilities. That's intriguing because we expected the opposite. We thought that, as in humans, more aggressive and more bold individuals would divorce more. So to better understand why we have that relationship, we have to look at population structure. Here on the x-axis, it's the age of the birds, and on the y-axis, it's the cumulative number of individuals available to breed. And we can see that at older ages, there's an excess of males. There are much more males available to breed compared to females. This also means that not all males can breed. There is high competition for access to reproduction between the males. And based on this, we believe that what's going on is that shy birds are forced to divorce. So if you imagine a shy bird that is in a partnership, when an intruder comes by, it is because it avoids confrontation most of the time. It's more likely to let the intruder take in and leave the nest. Whereas if we have a bold male that is already paired with a female, when an intruder comes in, the bold male is more likely to defend its partner towards that intruder and maintain the pair bond. I just want to come back to that figure for a second, because now we've explained that an excess of male can have consequences on pair bond dynamics. But why do we have more males? Or put it the other way, why do we have fewer females in the population? It's important to understand why, because if the females die more, then this creates widows in the population, and it can take a long time for those widows to find a new partner and start reproducing again. And we know that there are fewer females in the population because they die more compared to males. So as I said, it takes a long time for the widows to find a new partner. And to understand why there are more females that die, we have to look at what they do during breeding. Where do they go? So we assess their foraging behavior. We do that by using GPS tags. These are small devices that we put on the bird's back. So we attach them by glue, so it's easy to put on and remove if needed. And with those devices, we can track wherever they go, as we would do with your cell phones. And with those devices, here I just show a map where you have Crozet archipelago in the middle. And these are individual tracks around the colony during the breeding season. The first thing we learned from that is that we expected that they wouldn't go further than 1,000 kilometers away. But from those tracks, we now know that they can go as far as 3,000 kilometers away, which is really, really far. Another thing that we found out with those devices is that males and females do forage in very different grounds. So here is just a map that shows the core area where females in purple and males in blue go when they forage during the breeding season across Crozet Island. So you can see here that females forage much more to the north compared to males who forage more to the south and to the east. So they forage in different grounds. So what makes females more vulnerable to mortality in those foraging grounds in the north? The next thing that we do is that we looked at whether whether the individuals would encounter fishing vessels during their journeys. So here is a map of, again, Crozet Island in the middle, but there are other colonies where we did similar studies. And this shows, the tracks of individuals around those colonies when they breed. And in yellow is every time a wandering albatross encountered a fishing vessel during its foraging trip. And as you can see, most of them are located north of Crozet Island, where females forage. And we know that fishery bycatch is an important source of mortality for wandering albatross. For albatrosses in general, it's responsible for about 100,000 albatross deaths annually. It's really an important mortality cause. It's bycatch, so it's not intentional. The fishermen don't want to trap albatrosses. It just happens like that because albatrosses are attracted to the baits that they use on the hooks, and also they're attracted to the discards from the boats. But the albatross get attracted and they will try to get the food that is on the hooks. And because of that, they will get hooked and drown. And this is what it may look like from behind a fishing vessel. It's packed in albatrosses. For sure, it's free food, it's a buffet. So they are a lot attracted by fishing vessel, and it can be risky for them. And we know from the previous map that I showed you that females are the ones that encounter the most those fishing vessels and are thus more likely to die from it. We believe that fishery bycatch has been responsible for the decline in the population that we observed at Possession Island starting in 1970. So here on the y-axis, it's the number of breeding pairs. It's a proxy for us of population abundance. And we can see that starting in 1970, it drops. And we think it's associated with fishery bycatch because at that time, that's also when we recorded the highest intensity in fishing activity around Crozet archipelago. But when conservation agencies became aware of that, they started to suggest mitigation measures. So there are plenty mitigation measures that can be put in place, and here are 3 of those. The first one is to place bird scaring lines. So it's just attaching little colorful thingies on top of the lines, and this is supposed to scare away the birds. Another measure that can be put in place is to put weight on the hooks, so the hooks sink faster. Because it will sink faster, the albatrosses are less likely to get to the hooks and then get hooked. Also, albatrosses are day feeders. So if the fishery takes place during the night, then there are fewer chances of killing albatrosses when they conduct their activities. So these are some of the mitigation measures that can be used to reduce mortality of albatrosses by bycatch. At first, those mitigation measures were just, there were no real incentive for the fishermen to apply them. It was just based on voluntary actions. But now it has started since recently to be mandatory for all the fisheries. And when they started applying those mitigation measures, we really saw that the population started to recover from it. It's a slow recovery because, as I mentioned, reproduction is slow, so it takes time for the population to get back to its original levels. But still, for the wandering albatross at Crozet Archipelago, it seems to be working pretty well. It's a good news. But the wandering albatross is still in troubled water. According to the IUCN, the wandering albatross is considered now as vulnerable because there are other populations that are still declining. Here it's the population at South Georgia, and you can see a sharp decline in the number of breeding pairs. It's pretty steep and it's still ongoing. There, we believe that fishing activity is still really intense and mitigation measures have not been implemented the same way as it has been at Crozet Archipelago. So there are still a lot of things to do. But also, we know that the wandering albatross is affected by climate change. We have evidence that sea surface temperature is associated with juvenile survival. So when the water in the ocean warms up, juveniles die more from it. And if we don't allow the juveniles to come back to the breeding colony and reach that reproducing adult stage, then of course there will be fewer reproductions in the population, and this will contribute again to reducing population growth rate and size. So it's important to understand those links and to continue to study them. I'd like to finish my presentation by welcoming you to the Anthropocene. The Anthropocene is the new era we just entered in, which is characterized by dominance of humans on Earth. So we basically replaced the dinosaurs. But it doesn't have to be that negative. We often perceive the Anthropocene as a really negative thing. But I hope that with the example of the wandering albatross, it shows that it can also be positive. When fishermen, scientists, conservation agencies, and policymakers all work together, there are still things that we can do. And this work that I've presented today comes from collaboration with a lot of people that come from a lot of different places. I just wanted to take a couple of seconds to acknowledge their work. And I will also like to thank you all for listening to me today. Thank you.
All right, thank you so much. We will do the same Q&A. Maddie and Arlie have microphones, so just raise your hand and they'll come find you and get you a microphone. Looks like we have people already.
Cool. Hi, yeah. Is it still a sailor superstition to kill an albatross?
I have no idea, but I don't think it's a good omen, but I don't know.
Hi. Just curious, do juveniles have to return to their original colony in order to develop a pair bond?
Most of them will come back to the colony they hatched in, but not all of them. But yeah, they have knowledge of the breeding ground that may provide them an advantage compared to breeding somewhere else. But most of them will come back.
Are there different species of albatross or just the wandering albatross?
There are many species of albatross. I think on top of my head, maybe 22 species. You have some here, Blackfoot albatross, for instance. But yeah, a lot of them are in the southern hemisphere, but there are plenty of them. But the wandering is the biggest one.
You mentioned that shy males divorce more. Is there a possibility that like that personality can be bred out since they divorce more and the more like dominant ones are mating? Is it possible that that personality could just be completely bred out?
You mean that they will produce offspring that it will also have similar personality? Is that what you mean? Yeah, we're actually investigating that at the moment. We want to know if the likelihood of being of a certain personality type, it's something that can be inherited from your parents. So far, we have evidence that it is. It's small, but it is heritable.
With climate change and bycatch and stuff, have you noticed any like mixing of species, I guess?
You mean if they would breed different
Being
species
with-
together?
Yeah.
I don't know. I don't know if that can happen. We haven't noticed any of that. But since they really come back to breed at the same place every time, and different species, they don't share colonies with different species, I think it's not that likely.
Hey, you were talking about how males and females have different like hunting grounds and gathering grounds. Is there a certain reason for why that happens, or?
Yeah, it's a really good question. Actually, in other colonies, it's not the case. Males and females go forage in similar grounds. But at Crozet Archipelago, the resources are really limited. So they have to fight for access to resources. And in wandering albatross, male and females are not at the same size. Males are bigger than females, and they outcompete females when they go get food. So that's why females are forced to forage up northern from the breeding ground, and males go in richer waters south of the colony.
Do the wandering albatrosses feed on the surface, or do they dive? And if they dive, how deep do they dive?
I don't know exactly how deep, but I know that for the fishery bycatch, for example, the riskiest depth is within the first 10 meters. So I believe that's really within that first 10 meters. I don't know in feet, I'm sorry. Within those first 10 meters, that's where they do forage the most.
Is it on? Okay. So you mentioned the population of males being a lot higher than females. That being said, are there gay albatrosses?
Are they gay albatrosses? No idea. Well, I guess as with octopuses, we cannot, they can still try, but I don't know. Maybe, I don't know of any studies that would have shown that they pair with someone of the same sex. It could happen maybe temporarily, but I don't have any evidence of it, I'm sorry.
So how do you guys attach the trackers and rings onto their backs and feet? And when you do, like when the albatross dies, how do you deal with the like trackers and stuff still attached to them?
Yeah, well, of course, when they die, they disappear, and then we never retrieve those devices. So that's a risk we we're taking by attaching those to the bird's back, so we don't retrieve them. Those devices are pretty small, so they store the data in it, but not for a very long time, so we have to retrieve them physically to download the data. There are other devices. I worked with bears before, and because bears are really, really big, you can attach really big devices on them, and that store a lot of data, but they can also communicate the data through satellites, so you can get the information on your phone by SMS. But in this case, they're really small devices, and we have to recover them. If the bird dies, then it's gone with it. But then for the leg rings you were also asking about, this is just steel that we put on with twisters. Yeah, that's pretty easy.
What do the albatrosses generally forage for?
They're the type of food they're looking for.
Yeah.
Yeah. They mainly eat fish, but squid. Squid is their very favorite food item.
How many offspring does an albatross have in its life?
In its life? That's a good question. It depends on many different factors, but it can be up to maybe 10 maximum, because they live about 60 years and they start to breed at about 10 years old, and they breed every 2 years. So if they don't skip more reproduction than they do, then that's about like probably the maximum that they can get. 60 years old, it's the maximum they can live. So an average maybe between 5 and 12 offspring they can get.
In your study of the personalities, have you noticed any changes with like death or divorce of the pairs, like grieving or some other kind of behavioral changes in that time?
That's a good question. No, we haven't looked into that. This is really recent. We published that study a couple of months ago, so it's really recent. And it was the first time that anybody had assessed the link between pair bond and personality in a wild species. It's something that we do in humans, but in wild animal species, the link with divorce, it's something totally new. But yeah, there are probably other things that we can look for. And widowhood, I don't know how they react to being widow, but it's something that maybe they could look for in the wild.
Have you observed any chicks that have two parents that get divorced and seen that behavior get repeated through generations?
A chick that got two parents divorcing while raising the chick? Oops.
They've seen that behavior get repeated through watching other parents around them, I guess.
Yeah, it's a good question. The way we measure divorce is after the chick is fledged. So we look at how they pair together, but it's actually in the next reproductive event that we will see if they mate with the same partner or not. So the chicks are not aware that their parent will divorce the next year. So it's not something that they could learn from their parents. So if ever we see a relationship between the personality, the divorce probability of an offspring and its parent, it's more likely to be genetic rather than an acquired behavior.
You said you switched from using Bessie the cow to just humans,
Yeah.
and I'm wondering if the research has been going on for so many decades, are humans truly a novel thing for these birds?
That's a good question, something we don't know. But it will be the same with Betsy at some point, because we've been doing those personality assessments since 2008. So there's for sure some kind of habituation there. It's hard to tell, but yeah, for sure. I don't know if at some point we'll have to change the way we do those assessments, because we approach the nest to catch them and tag them. So of course, and we do that since 1966. So yeah, but we stay there only 2 months during the year. So the rest of the time, they're unaware of us being there.
Yes. Do we know how many colonies we have of wandering albatross, globally, and also of those populations which are considered vulnerable or critically endangered?
Yeah, I don't have the exact number, but there are quite a few. I know there are some in Australia, New Zealand, South Africa, and all of these French islands. So I don't know. Guess would be maybe 10, 15 colonies. I know of maybe 4 or 5 that are studied as well. And what was the rest of your question? Sorry, I forgot it.
Just of those, or any of those populations vulnerable or endangered?
Yeah, most of them are actually declining. So the one at Crozet Island is one of the good examples of recovery. But the other ones are in decline, especially those that are closer to human habitations, because the one big problem that we now start to observe is plastic in their stomach. It has become a really big issue, especially for the chicks. So the parents bring the chicks plastic to feed on, so it's not a good food source to grow.
So how do you know that it's like just the fishing boats that's causing the population decline, or could there be other factors like a lack of food source in the area where the females are? Or I guess you just mentioned plastics just affecting the females. How do you know what exactly is affecting what?
We cannot say for sure that it's the fishing industries. It's just we have evidence that both population decline and fishing intensity in that area that is really critical have kind of happened at the same time. So it's circumstantial evidence of it. We don't have any proof, but we know for sure that albatrosses die from it in large numbers.
Okay, we just have time for one more question right over here.
What is it about the albatross that made you want to study it, as opposed to studying, say, penguins or eagles?
It's a good question. Actually, I'm more used to studying large carnivores. I studied seals and brown bears, or grizzlies, as you call it here. So for me, it was a big change, getting to seabird ecology. But what I presented today is much more a behavioral ecology, but I study population ecology mostly. So I'm interested in understanding what causes those fluctuations in population abundance. And wandering albatross is a really good example of a study that has been going on for such a long time that we have good information about what's going on. So for me, it was mostly about like the quality of the information that we have from that study site that allows me to understand a little bit more the population dynamics there. But it's a really fantastic species. It doesn't have that big teeth, but they're really, really interesting as well.
Okay, let's give another round of applause for Joanie.